In Year 12, when we were first introduced to complex numbers, we were promised that we would be shown how to differentiate a complex function. Now, 1 year later, we have been shown how to, and have developed this Maths Without a Mark Scheme project, in which we try to explain complex differentiation in a way that would make sense and accessible to others. We have probably had a little bit too much fun working on this.
What is a complex number? Imaginary numbers were created for solving cubic and quartic equations in the 16th centuries, where mathematicians began to need to be able to find the square roots of negative numbers. Although described as impossible by Newton, they are extremely useful and have been widely accepted since the 1800s.
A complex number is a number that has a real and an imaginary part. It can be written in the form z equals a plus bi, where a and b are real coefficients. So b is a real coefficient of an imaginary part. I denotes the standard imaginary unit where I equals the square root of minus 1, therefore I squared equals minus 1.
The complex number z equals 2 plus 3i, the real part of z, me z, equals 2, and the imaginary part of z, in z, equals 3. This shows that z is the real coefficient of the imaginary part. This demonstrates how 3 is a real number, and as such is the coefficient of the unitary imaginary unit.
A complex number z equals a plus bi can be represented on an Argand diagram where the x-axis represents the real part of the number and the y-axis the imaginary part of the number. Unlike real numbers, complex numbers are two-dimensional and therefore form a plane in their own right. Understanding this is fundamental for what is going to come.